Have you ever wondered, how can I control the lights? How can I control electric motors? How can I use and program different sensors? How can I make a robot that cleans my room so people will stop talking about the state of cleanliness in my room? What's that? When are you going to clean up your room? Yes, I will make myself a robot that cleans my room one of these days. But to start making a robot, I need to learn the basics. Let's start by controlling an LED. There are several ways to control an LED. In this video, we will do it with the software called Arduino IDE, which stands for Integrated Development Environment. In other words, it is a program made up of a set of programming tools that allow us to integrate more programming into it in order to comply with our desired functions. The language that we will use to program will be in C++. We will also be using an Arduino board, but more on that later. First, we go to the official Arduino website. We do this by a quick search in Google. We type Arduino. We click in the first link. Within the page, we will see different links, starting from what's Arduino to how to use its different tools. You can search for Arduino projects and what has been developed with their systems. I advise you to read it when you have the time. You will find interesting topics. But for the moment, we will start downloading the software. We click on Software. It will take us to the download window. We select the system that we are using. In my case, it will be Windows. We click on the letters. It will ask us if we want to make a donation for the software that they provide for free. If you want to contribute to its development, select an amount, and then fill your payment information. For now, I will proceed to just download. Once I click it, it will start the download on your computer. The page will ask you if you want to answer some questions as feedback for them. The file to be downloaded contains about 162 megabytes. It will take a few seconds to download. It's ready. When the download is finished, click on the downloaded icon either from the page or within any folder. Go to Downloads, and here is our file. We click twice. It asks us if we want to accept terms and conditions. We click on Accept, otherwise we can't use it. It will ask us who do we allow to use this program. In my case, it will be just me, so we click on Next. Where we want to install it. It's ready! You have the software installed. Now let's do tests with Arduino board. And what's an Arduino Uno board? Well, by board, I mean the forms of electronic planks known as PCBs, or printed circuit board, which are made up of tracks, holes, and bias that are made of conductive materials laminated on a non-conductive base. These, when combined with various electronic components, allow us to perform various functions according to our desires. In the case of Arduino Uno, and particularly the model that I will be using for this presentation, it consists mainly of the ATmega 3289P-PU microcontroller. But what's a microcontroller? Well, it is a programmable integrated circuit capable of executing your orders written in the code recorded in the memory of the microcontroller. These circuits are made of several function blocks that fulfill a specific task. A microcontroller includes within three main functional units of a computer, which are central processing unit, memory, input and output peripherals, the pins. In the case of the Arduino board, when we combine it with the microcontroller, we obtain a circuit board that makes our electronic connections. Let's perform a test with the software and the Arduino board. We connect our USB cable to the computer, and the other end, that is a USB Type-B, to our Arduino board. In the software, we look for tools, board, Arduino boards. In my case, I will be using an Arduino Uno. Then we open Tools again and we look for the port to which is connected. Now we go to File, Examples, Basics, Blink. A new window will open, which will have the code already written, which we can load to the Arduino board to control its integrated LED light on pin 13. In this code, we can appreciate the order that the microcontroller will get to produce the expected signals. In this case, the code starts from void setup. Double slash and slash asterisk ending with asterisk slash are ways to add comments to your code. It is useful to understand what your code says if you forget in the future. Pin mode, it is used to configure the specific pin that you want to use as either input or output. Within pin mode, we find LED built in, which is the internal LED connected to pin 13. Output symbolizes that pin 13 will be used to send a signal. And what signal will it send? Well, in void loop, what is written inside the brackets will be repeated constantly until the Arduino runs out of power. And what will be constantly repeating itself? In this case, pin 13 will send a digital output signal, that is 0 or 1, true or false, on or off, up or down, or high and low. This signal will be sent every 1000 milliseconds, that is 1 second. What if I want the change over time to be different? Well, we can modify its time by changing the number of milliseconds that have to pass after each command. Remember, most of the codes are executed from top to bottom. To upload the program to your Arduino, click on Upload. If you want to make sure the code does not have any errors, click on Verify. The code does not have any errors. We proceed to upload. Very well, everything works as it should. What if we change the time it takes high to change to low? Let's change the delay value to 500. Now load the program again. We can see the LED emits light faster. Now what if I want to control an LED like this one, besides the one I already have built in internally on the board? Very easy, we need a resistor. LEDs are polarized. In other words, it matters how you connect them. The positive side is called anode and the negative side is called cathode. If you look inside the LED, you can identify the negative being the one that covers most internally and the positive being the small part. Another way to identify them is through their pins. The shortest is the negative and the longest is the positive. As you already might know, LED stands for light emitting diode. And like diodes, LEDs allow current to pass only in one direction, from the anode to the cathode. Since the current flows from positive to negative, the anode will have to be connected to an output pin of 5 volts, and the cathode will be connected to ground. But first we have to put a resistor. We can put it between ground and cathode or between the 5 volts output to the anode. This is possible since the resistors are not polarized, so you don't have to worry much about their orientation. And why do we need resistors for LEDs? Well, it helps us to have the limit of current flowing through the LED. In exchange, it helps us to prolong its useful life. But notice, the greater the resistor's capacity, the greater the restriction of flow of electrical current through the LED will be. Therefore, less luminosity. Then it is necessary to find the appropriate point for the resistor. In this case, and for the type of LED I will be using for the Arduino board, I will use a 220 ohms resistor. I will also use cables with male pins on both ends and a circuit board to make our connections. Remember that it's recommended to disconnect the power source of the Arduino while making connections. Let's connect a wire to pin 13, followed by the resistor that will be connected to the anode of the LED. At the cathode, the wire will have a shared ground on the circuit board. Ground is found as GND in the Arduino board. We connect the Arduino, and since it already has the program recorded in its memory, it executes the last code that was loaded. Note that the integrated LED and the LED connected to pin 13 send the digital signal at the same time. This is because they are connected in series. What if we add more LEDs to the Arduino? First, we choose which other pins will be connected to the LEDs to receive the signal. I will use pin 10 and pin 5. We connect them together with their resistors. We go to the software. In my case, I like to create a new sketch. I copy the sample code. I paste it on the new sketch. Then inside setup, I will add another pin mode, parentheses, 10, comma, output in capital letters, then close parentheses, And one of the most important details in some programming languages, semicolon. There will come times when your code will give you error because you are missing a semicolon. We repeat it, but this time with pin 5, then in loop, we will send digital signals to pin 10 and 5. We can also change LED built-in to 13. We can copy and paste to save ourselves work. I'm just going to edit a little bit. I will add comments to identify them and change the value to the corresponding pin. And now let's load the program. It works. As we can see in loop, the code is constantly being checked and executed in order from top to bottom, turning pin 13 on first, waits half a second, turns it off, it waits another half a second to turn pin 10 on, and so on. What if we want all the LEDs to light at the same time? We will have to modify the code in the following way. We put the highs all together in one section, and then we put the lows all together in another section. And at the end of each section, we put a delay. We can delete the other delays. We load the program. And now all the LEDs are turning on and off at the same time. And what if I want them to light from right to left? Well, we can add a delay after each high and each low. Funny, right? Try different techniques yourself. It's a good way to learn programming. This is all for today, but there are more projects on the way from which we will learn various topics like programming, 3D design and animation, virtual and augmented reality, game development, robotics, CNC, manufacturing, and much more. If you enjoyed this video, let me know by giving it a like, subscribing, and remember, share the knowledge. If you have any questions, feel free to ask me in the section below, and I will gladly answer you. Thank you, and goodbye.